So now we're going to move to our main type of motion, which is the projectile. The projectile is what you have thing that moving in X and Y direction at the same time. As you see the ball moving here, it's moving upward, at the same time it's moving forward. So that the curve or this path of the ball movement happen. So this is the diagram of the projectile. As you can see, the initial velocity can break through Vx components, which is I will write down as a u because it's initial velocity, and also uy components. And with the time change, in this case, you have the influence of the g acceleration only. Now ux is moving with the constant speed because ax is zeros, but ay is equal to minus g. So that uv will change to v with any time relation because some acceleration influence to the velocities. And we will explain more in the detail. So this is what happened. As I said, there's no acceleration in x component, but the acceleration in y component for this projectile. The early problems, it state about the acceleration in x-axis, not y-axis, but now things is changed. This is what happened in our real life when you try to shoot the basketball or kick the football out and have the curve path or curve motion, right? So what we always have here, we fix the frame as upwards as a plus y, and maybe on the right as a plus x. And when particle moving to this direction, you get the plus sign to its velocity. When it's moving upward, you give plus sign to its initial velocity. But you can see the acceleration of y is moving downwards, so you give the minus sign to g in j direction, like this. As you look further, you will see the initial velocity v0 or u. You can break this component to x and y components, and we learned this. If it's close to the angle, you got this as the u cos theta. This is your ux. And when you break further away from the angle, you got u sin theta. This is your component in y. And with this motion, you know, in x direction is moving with the constant speed. So you will have this equation for explain about the displacement along the x-axis. How about the y direction? From your four main equation, you can pick up the third equation, right? And you have the minus sign here because of your g. With the relation of these two equations, you can use the first one to determine the time that this object moving. So now you got the t out of the first equation. If this is your first one, this is your second one. From first equation, you can rearrange and you get the time, and you sub the time. So the fourth one is substitution of we call this third equation, third into 2. You sub the time in over here and over here. What you get the final relation of y and x squared, which is, this is the form of the parabolic motion, right? The parabolic gonna curve against y-axis because it's power 1 and this is power 2, x squared over 2. This is the definition of parabolic motion, or in our definition is projectile. Like the trajectory is quite simple and basic algebra that we have learned. So these are all the trajectories and what we can substitution in, because what we break down the initial velocity, the u of it, and you can break to u cos theta as your vx. You can sub this information in, and also uy, which is u sine theta over here. And you can use this relation to determine whether it's the motion of it or anything that you want. So this is the proof of the parabolic pathway. This is the example 4.3. We would like to determine the range, which is the distance from the first point to the final point that this particle moving upward and reaching down to the ground. And the height, which is the maximum height of this pathway h. So we would like to determine from this relation, since you know the acceleration that involved into the projectile motion is happen only in y direction. So this is the ay pointing downward, so it's minus g is what happened in ay. How about the ax? Even the particle moving along x-axis and y-axis at the same time, in x direction they have no acceleration. Right? This is the nature of the simple symmetrical projectile. But at some case, if you have some acceleration in x-axis can be happen if you have some thrust or force involved. But in this case, we ignore the influence of the acceleration in x-axis. So what happened when this particle or this object have the initial velocity vi or u as the initial velocity, it can go upward and go forward because your u is not only in y direction, it's also in x direction. Since you break the components in your x component, you got u cos theta I, and for y component you got as u sine theta I. So you can write down u as the vi as well, because this is your initial velocity. I will sub in later, but because I don't want to involve with a lot of the subscription. And what happened? So when the time go on, so this particle moving upward due to the u sine theta, when it reached to the maximum point, the definition of the free falling, when your vx equal to 0, that means you reach the maximum position, right? Because it's go upward and cannot go further. This is like your maximum velocity. It can push you up, and then after this particle gonna fall down, right? So that when y equal to 0, it means you have the maximum height. So from this relation, we can now use for determine the range of this part and the height of this part as well. Let's start from this. If you look after the motion along y-axis, so we look at the y-axis first. What is happening? The particle moving upward with the u sine theta I initial velocity, right? This is your uy components. It's moved upward to the maximum position. So it's turned that you have your vy equal to 0. So you like to determine whether how long does it take to the maximum position. So that means when it's going to the maximum position, it's going to moving toward the middle position, which is this distance is r over 2. And you can use the relation of time to find the total r or even the height as well. So now we can write down the relation. So if I pick up the condition that I can use for finding the t, I have 4 major kinematics equation, right? This is going to look like kinetic equation. So for kinematics equation, which is I will revise to you now. V equal to V0 plus AT, and S equal to V plus V0 over 2T, S equal to V0T plus 1 over 2 AT square, and also V square equal to V0 square plus 2AS. From these 4 equations, just select one to complete relation to find the T. I will choose the first equation and define only in terms of y-axis now. So now we get Vy equal to V0y, which is this is you can rewrite as your Uy, right? And plus AT. And you can sub all the information that you already known in, right? Because it's reaching to the maximum point. So your Vy is 0. This is at H max. And what happened to U here? You know U is from U sine theta. So you got 0 equal to U sine theta. And your A is from different direction because the upward is plus, so the downward is minus GT. So finally you got T equal to U sine theta over G. This is the time that particle used for moving from the ground with initial U, Y to the maximum point. Now you know the time that take this particle to the maximum position. So if you would like to find the H or the maximum position, which equation you're going to use? So I will pick up the equation number 2 from this case. So you're gonna get H equal to V plus V0 over 2 and multiply by T. And all these only in Y components. So that you know the maximum is Vy is 0. So you only got the V0Y term. So you get U sine theta over here because it's Y over 2 from this part, and multiply with this is your time, another U sine theta over G. So finally you're gonna get H max. So your H max here is U square sine square theta over 2G. Now you can find the height or maximum height or H here as U square sine square over 2G. So from this you got H max equal to Vi square sine square theta I over 2G. This is your H that you look after, because all the parameters asking about Vi, theta I and G.